Good morning. I am K. Palanivel, Assistant Professor of Mathematics, SNS College of Technology, Coimbatore. Today, I am going to the topic, the design of experiments in Latin square. Already we have to see the randomized block design and completely randomized design. Completely randomized design is the one-way classification. Randomized block design is the two-way classification. Latin square design is maybe we told three-way classification. Why? Completely randomized design calculate between row or column. Randomized block design we calculate row and column. Latin square design we analysis row, column and treatments. Going to the problem, an agriculturist wants to test the effects of 4 different fertilizers A, B, C and D on the yield of budi in order to eliminate sources of error due to variability in self-fertility. He used the fertilizers in a Latin square arrangements given below, where the numbers indicate yields in quintals per unit area. Perform an analysis of variance to decide whether there is a difference between the fertilizers at 5% level of significance. The given the values of A, D and the alternating series A, D, C, B and D, C values are there. First of all, the numbers are 2-digit numbers. Try to calculate the single digit numbers. There are all of you commonly we have to subtract 18. We can follow the table. Take the values, given values are x1, x2, x3 and row wise y1, y2, y3, y4. Solving this problem in tabular column, summation x1 equal to 5, summation x1 equal to 2, summation x3 equal to 1 and summation x4 equal to minus 1 and the total value is 7. Summation x1 square equal to 41, summation x2 square equal to 58, summation x3 square equal to 147 and summation x4 square equal to 87. These are the values. We have to find the first of all H0 and H1. H0 means null hypothesis and H1 means alternative hypothesis. H0, there is no difference between the fertilizers. H1 means there is difference between the fertilizers. T, the total value is T, summation x1 plus summation x2 plus summation x3 plus summation x4. There also total is 7. N equal to n1, n2, n3, n4 equally 4, up n equal to 16. To find the correction factor CF equal to T square by N. T square by N. The value is 3.0625. Next, to find total sum of squares. Total sum of square means formula is TSS equal to summation x1 square plus summation x2 square plus summation x3 square plus summation x4 square minus correction factor. The value is 329.94. SSC equal to sum of square between column. So summation x1 the whole square by n1 plus summation x2 the whole square by n2 plus summation x3 the whole square by n3 plus summation x4 the whole square by n4 minus correction factor equal to the value is 4.6875. There also SSR also the row wise y1, y2, y3 values. We get the values are 6.6875. Next, to find SST, ABCD values, arranging the values in ABCD and take the values are A equal to Z1, B row is Z2, C row is Z3, D row is Z4. So the formula is the same as SSC and SSR. The summation Z1 whole square by 4. 4 is the value, number of values in the rows. The SST value is finally 284.1875. Finally, sum of square between error is 34.375. The ANOVA table, the following the ANOVA table, the form the ANOVA table. In this value is FC, FR and FT values is find out. FC is accepted and FR row column value is accepted, row value is accepted and the treatment value is rejected. Reason is calculation value is greater than the tabulated value, therefore the H0 is rejected. Therefore finally there is difference between the fertilizers. Thank you for watching.